Hello, everybody, and welcome back to Python WebConf Track 3 Cloud. This is the final day, day 5. I feel like we've been doing this forever now, but it's been a really, really awesome time. I am joined here by Anastasiia. She's going to be having an awesome presentation about can we deploy yet? That is always the question, isn't it?
So we're going to start this talk about how can we make sure that our Python code is ready for production, is ready for deployment. My name is Anastasiia. I'm originally from Ukraine, and I'm connecting today from Berlin. Actually, I'm living here since 5 years already, and I'm a lead developer at ScoutB in Berlin. I'm also one of the organizers of PyBerlin meetup, and you're also all invited if you're interested. I have around 10 years of experience, maybe a bit more now, in software development, and most of the time, I developed in Python. I came for the language because it was really simple to start, and I didn't really like it at the beginning, but then I fell in love with the community, and I simply could not live for anything else at all. So Python is still my preferred language, and this talk today is also about Python. So we're going to check lots of code snippets and also some demos, and you would see how to improve your production code. So today it's not about me, it's about you and your code. What does production mean to you? If there would be an in-person event, I would ask you how many people are running code, Python code in production environment. Some people do, some people don't. And this talk would be useful for anyone. It doesn't matter if you have it on production or not, you still can run those checks, which I'm going to mention, and then see what can you improve. So production, the only difference between production and non-production environment is that there is a user. There is a user in production environment, and this user doesn't really know why was this code built and what to do. So our task is to make sure that the user will not break the code, even if they're trying to. And of course, they would try to. From our point of view as developers, we know how everything works. We can see where to click, we know what to do next. But for user, it's not obvious enough. And if they see some issues, some errors on the screen, they have no idea what's happening. They would panic, or maybe they would even leave the website and then go to some other service, or maybe they will call support. And sometimes people like doing things in non-working hours, and they cannot contact support. So that would be sort of panic, and then some users might leave the platform. With that said, how to actually check if your code is ready for production? I really like this quote from a Release It book, and I'm going to read it. You worked hard on your project. It looks like all the features are actually complete, and most of them even have tests. You can breathe a sigh of relief. You're done, or are you? The question here, how to check if you're done, if you're ready for this stress test with the user or not. And there are a couple of checks for you. I prepared the list with bullet points, and you can also take notes. It's going to be a really, I would say, heavy talk with lots of information, because all of those checks, they're not about one specific place in the code you can check, but that's actually a general, big, long list with all the checks you can do, you have to do. So let's start. You can already start taking notes. The first thing what you need to check is the exception handling. We will take a look at each of the bullet points I'm saying right now, one by one, after this slide. So the first one, exception handling. Then the next one is how to either become a detective in your application, or how to set up a proper, meaningful login system for your application. Then the next one would be how to do proper code reviews in production, or how to automate it more and then set up effective CI/CD pipelines. The next one would be Docker, how to easily set up Docker images, how to secure them, and how to make sure that you are downloading the right image. And then after we will take a look at those specifics, I would give you some ideas and maybe hints where to take a look, what to read, and also what can you do more about that. So let's start. I'm already excited to share my knowledge and my experience with this. I had lots of different applications working on production in the game development sphere, in business development, web applications, also different types of applications, but everywhere where user is involved, you need to make sure that you're not showing 500 internal server error to the user, that it's handled somehow, and then you're showing what the user should do and what happened. Of course, we don't want to show that, so we're trying to handle the exception. In Python, how do we do it in Python? We do try except block, and then we are just trying to do something with exception. In this case, we are simply silencing the exception by printing it and then not doing anything, which is not quite nice. And I wouldn't suggest you to silence exceptions. I would suggest you to handle exceptions. That means that if you caught the exception and you know what to do with the exception, take actions and, of course, log what happened in there to reproduce it in the future. But at the same time, you need to keep an eye on which exception to catch first. There are exceptions and also base exceptions. What is the difference between them? Maybe it's not quite obvious, or maybe it is obvious, but in this try except block, we are trying to get all the exceptions and all the base exceptions. And for example, if we have this piece of code, we are waiting for some input from the keyboard. And after that, we're trying to get catch the exception and base exception. What if you would try to interrupt this program with keyboard interruption? For example, Control-C. What will happen in this case? You will get the exception, keyboard interrupt, and it would be under the base exception. So I would not suggest to catching those exceptions, the base exception, because you might get something unexpected, something that you don't want to silence if you have only prints, or maybe something that you don't even need to catch. This happens because hierarchy of the exceptions is like that. There is a base exception on the top, and then the exceptions under it are system exit, keyboard interrupt, generator exit, and exception itself. So I think that the highest level of the exception that you can catch and would be exception, just a normal exception, because we don't want to catch any keyboard interrupts. In our case, if we are going to silence it with the print, then we are not going to get right results, and maybe our program will not be even able to finish, so we will have to kill the application instead. With that said, the question afterwards would be how to handle exceptions. Let's imagine that we are trying to catch the exception, we got it, we are printing something on the screen, so we would find out what happened afterwards. And then we are trying to handle the exception and rewrite it again. So if we don't know what to do with this exception, we need to raise it to another block where maybe we know what to do with this exception. In this case, if we are trying to catch the exception, for example, exception, with some of the messages, in this case, it would be something custom happened, and then we want to change the message of it. So we would rise exception, the custom exception, with another message. I want my custom message. In the end, as a result, we would get something like this. During handling of the above exception, another exception occurred. It's not quite pretty, and that's not what we would like to have, because then we're like lost which exception actually happened first. And I don't recommend rising any exception while trying to handle one. That also might happen, but not when you're doing that manually. How can we improve that? It's super easy. We can inherit exception from the one that we got. For example, we got this exception as E, and then we're trying to rise the new exception with the new message from the same exception. So then we would get in the end this result. The above exception was the direct cause of the following exception. So then we have both the new message and the old message. Looks good, right? The next step would be have our custom exceptions. So those custom exceptions are the ones that we can rise. We can also try to handle them, and we know exactly when this exception is raised, because we are doing that on purpose. And that would be also nice for handling afterwards. And if you want to know more about exceptions, we're not going to stop on all the secrets of them, but I highly recommend you to watch this talk, Exceptional Exceptions, by Maria Corjero, about exceptions and all the secrets. Let's go to the next step. The next step is logging. A few years ago, 12-factor app was super popular, and it was quite good pattern to build all your applications based on the principles from the 12-factor app. It's not super popular anymore, but I really like how they treat the logs and how they explain why do we need the logs in general. That's why I included in here. So we need to treat the logs as event streams, and logs should provide visibility into the behavior of our application. How do we do that? There are some principles which are the attributes of the logs. So the main attributes are when, where, what, who, and the outcome. The when is super simple. It's easy to add the timestamp in any of the login message, where you can also put the path of the file, of the module, to the log message. It's also easily included. And also what happened, that could be just a message. And then who, that could be either a user or maybe any kind of tracing, which service. And then the end result, the outcome. So what actually happened. It could be either a message or maybe a log level or exception or anything that we would like to log. So then how do we usually do that in Python? Usually we use login module, and then we are trying to write something into the screen. For example, we need to log the conference name, the talk name, and then some key ID. If we're using this library, then we would get something like this. It's not quite readable. If you want to parse the logs and then you want to build some kind of dashboards based on that, or maybe even if you need to find your issue, the exception, or maybe some kind of information that would help you to solve what happened on the live system, because there are thousands, hundreds, depends on the time of the event of logs. And then you cannot really parse them with machine. You need to write all the special parsers for each type of logging. And that's super inconvenient. If you have a DevOps team, for example, doing the parsing of the logs, that would be their like biggest pain, because if you have lots of services and they're all writing logs in different way, that would be really hard to manage that. So how can we improve logging? Maybe let's see, maybe struct log can help us to improve the code. By my smile, probably you can imagine that I used it in production. Well, yes, I did. And I really like it. And I really want to convince you to use it. So let's try and see how can improve our life. If we use struct log, for example, the log entry would look like this. So the initial message, we have the initial message, and then we have key value pairs. And it would look pretty nicely. And we can also combine that with a timestamp, with a path to the file, so where it actually happened. We can add many more features, different processors. And it's everything that comes out of the box from the struct log. We don't need to do anything else specifically to have this beautiful outcome, the key and then the value after it. Super easy to parse. So I would definitely recommend you to use struct log, but let's have a closer look on how can we even further improve the logging. This is an example of using the struct log and then adding some extra values into every log message entry. For example, we want to log a conference name, key ID, and then the talk name in every log entry that we have. Of course, we don't want to copy paste the code, but we can actually bind it into our logger. So the function bind will create a new logger instance. So you need to assign it back with this logger having those 3 key value pairs already in place. And whenever you log some either exception or error or info or any other level, it will have those 3 key value pairs plus anything extra that you write. In our case, it's just a login exception, some kind of message. And after all, it would have all of the ones we have. And also one trick, there is exception. So when we are logging anything with a struct log, there's no way to say, please turn on the traceback as in the standard logger, because that used to be also a key value pair as an option. You just need to set it true in the standard logger, but in the struct log, every key value pair is just a key value pair. So if you use it here, it would have the same effect as any other key value pair. And if you want to include the traceback, the logger.exception would give you the same effect. It would automatically include traceback. Of course, there are other options to do so, but this would be like super convenient and super easy, and it looks really beautifully. And one more trick would be using the JSON format. You can simply define how would you like to look your logs to look like, and then it will have everything in JSON. You can simply super easily parse it, and then it's just super beautiful. And now it's a demo time. Okay, so we have our basic idea is to transform this standard log message into something else. So the basic struct log setup, as I showed you before, would be basing on the standard logger. So we're trying to set up the standard logger with log level. And then we are using the struct log. This is the standard, and this is the struct log. So they have pretty much the same message, but it looks completely different. You see, this one has a key value pairs. This is our struct log message, and this one is the standard logger, just all in one message. Then there are different features. This is the bind function. And if you want to make sure that those two will have the same information that we used in the bind function, you can just run this function and then you would see. So this is the first log message, this is the second log message, and then they all have the same conference name, key ID, and then the doc name. The JSON format. Apart from JSON format, you can also define a custom log level. It's super simple. You just need to define the log level with the number, where do you want to put it, and also define a function itself. And then in the end, you can use your awesome conf log level, and then it would print on the screen that this is your log level. So this is an example in the JSON format. And here is the level. This is like a standard one. This is the fantastic, awesome one that we just defined. Okay, JSON format. There are different configurations. You can add different processors. This is not only about JSON format, but also you can use any extra information. For example, here we're adding the timestamp. Then also we are formatting positional arguments, the key value pairs, so it would be more readable. Then we're adding the logger name, then the log name level. It's all super simple. You just need to add the processors, as many as you need, and then it will simply work.
Anastasia, real quick, we have a couple questions. Is that okay?
Yes, we can have a few questions. Sure.
Okay, I just want to make sure I ask them and we don't lose them in place because they're kind of specific. Sean asks, can the bind take a variable for the value so we can increment the key ID?
Maybe you wanted, I think, something like, I have an example somewhere, maybe processors. Bind, no, I don't think that bind can get any variable that could be incrementable, but you can add, you can write your own processor. I didn't actually try to use bind for that, but you can write any custom processor. For example, this one that would add the timestamp, this one would process anything, and you can attach it to every log entry as well. So in this way, if you need to log some variable or you need to change content of the log message, you can write it specifically and then just add it as a specific processor.
Mm-hmm. Yeah, they were talking about the bind method for struct log.
Yeah.
That's what they're talking about. So cool. And then also, does struct log support a conf file similar to logging module? To a logging module.
Actually, I didn't try the configuration file. Maybe it does. So I didn't really try. Maybe for the next talk, I can try it out and let you know.
Awesome. Thank you. Sorry for interrupting your flow. I just want to make sure those didn't get lost in the whole demo.
No worries. So actually for the bind function, I don't really know if it works like that. I did try the static ones, not sure how to do the incremental ones, but I did try changing the behaviors with processors because I also had a custom need of logging some custom variable. So I just wrote the processor, and I also needed to send some extra information into Sentry to keep an eye on the exceptions. So I also wrote the custom processor, which will also send information into Sentry. So that would probably solve the issue, the first question. Okay, so the demo is over and we can move to the next point. I highly recommend you to watch this talk about logging. There are more examples, and also there are examples about European customers, about ideas what not to log, what to log. So definitely something that I didn't cover today. The next point, effective CI/CD pipelines. Continuous integration, that's a practice that would implement frequently running checks. So you can automate any kind of manual steps on the code review. You can automate with the continuous integration, and then you can run it on every commit message. They could provide test coverage, reliability, because it would be running on every commit message, and every also push into main branch or into development branch, depending on how would you set it up. Then fault isolation, because it would be running into your Docker environment, so it would be not relying on your local machine, on your local environment, and that would provide isolation from any other environments outside. And also that would be super transparent, because if you push some changes, you don't need to run anything manually. It would be automatic. And then before going to the code review, you can automate so many steps in the CI. So highly recommend to try that. Of course, code quality would be improved, and then it would lead to the faster development cycle. And your code review process would be improved on its own, because you don't need to fight over some standards. You don't need to win, I don't know, spaces or tabs, or single quotes or double quotes in the messages, but that would be automatically set up on the CI, and then it would be automatically checked. So there are different solutions for the continuous integration. There are self-hosted solutions, there are paid solutions, and also there are some free for open source. For this demo, I have chosen GitHub Actions because it's super simple. It has lots of different options, and depending on your purpose of this package specifically, you can choose one of those. For example, if you want to publish Python package, or if you want to just have some Python package, but you don't want to publish it, or maybe if you have just Django application, feel free to try it out. It's also free for open source applications. Super simple. If you hit the set up this workflow, it will generate a file automatically. It would add all the basic checkers out of the box, and then you can change them and tweak them based on what you need. So what I wanted to show you in the demo was actually this repo, where I did a pre-setup of Python application. I will quickly go through it. It's super automatic, super easy. So those are the workflows which are running on every push to all the branches. And then you can also set up a new workflow, choose this one, for example, or any other ones. You see there are even more options, and it would be pre-setup. It looks exactly like this. This is pretty standard. I just did add a couple of checks, extra checks. I added documentation coverage, for example. So this check would check what is the coverage of your documentation. So it would check all the doc strings, how many of them you have. And you can also have 80% coverage, for example, for all new files or for the entire code. You can set it up, and you can have also a file for all the setups of this. And one more thing I wanted to show you is, I don't see it here because it's not merged. I think it's this one. So there is a PR which I created today for the stock, which is called fail on error. For example, this was failed. If we go to the checks, we can see that this CI is green. If you click on the CI, you can have all the details. For example, if we go to PyTest, there is an error, like no tests. Fantastic. But the CI is green. Okay, this is all right. documentation coverage, also red. So it also failed, but the CI is green. That's weird. It's not actually weird. It's because I had this option, true, continue on error. So no matter if the step is failing or not, it would continue on error to the next step. That means that you silence all the checks. It's not good, and I recommend you to remove all of them. So in this case, I removed all of them, and if you go to the checks and you see this application, you see the CI is already green, the red, and the first test, PyTest, already failed. So it didn't let me to proceed to the next ones. That was it for the CI, and now the most fun part about Docker. So a few words about Docker images and how to secure them. I will show a super small demo as well. Try not to use the root user. I will stop on that in a second. The next one, use trusted and well-known images. Always check the authenticity of the image you are using in your Docker file. Also use copy instead of add. There is also a reason why you need to use copy, despite the fact that they're super similar, but the add function is less transparent than the copy. It could have a bit more features that are not super obvious. That's why in the best practices, it's recommended to use a copy function, which makes everything obvious. It just copies the file from the location to the location. Then lint your Docker file. There is a Docker file linters. You can also use them on the CI as an extra step to lint the files and check if they're secure enough. And also, if you are using some specific images with specific versions, try to save in your private Docker registry and maintain them. Because sometimes if you're, for example, using Python 2.2 for your packages or something super specific, those images could be disappearing at some point. And then you will have lots of trouble trying to change either your Docker file and then try to run on different environment which still exists, or trying to find the image somehow from different sources. And then you cannot really make sure that it's the same image that it was. And also you need to make sure that the Docker images are authentic, and then those are the images that you really need, because that could be harmful. Let's stop on the most important part. Which user are you using for your production Docker images? You could be using a root user or any other user, but the idea is to have, for the application, to have the least privilege possible. So the least possible for this custom task. That means that application should have only access to the resources that it needs for this required function. It's always a good idea because, for example, some process can have unexpected behavior, unexpected consequences, and you cannot really control if you give root access to it. So this is the way how to have a specific user and how to use it in the Docker image. Feel free to take a screenshot of it. And I'm going to show you something super interesting, super quickly. So the same example as we just saw, let's check the Docker file image. In this Docker file, this is the super simple one. It's created by Tiangolo, and then it's uvicorn, guvicorn, Python 3.7. First advice, be specific in the versions of the image. Do not use like generic Python 3 because you'd never know which image is inside. And the first advice you remember in those bullet points was check the authenticity of the image and check if this image could be trusted. So let's check. In this application, I'm using FastAPI, and I needed a specific image for FastAPI. So I just went to FastAPI, and then I saw that this is the creator of FastAPI. Of course, I want to use authentic image. So I went to the Docker Hub, and then I found this image from the same creator. You can see in here, it leads to the creator himself, and then you can see that this is the same user. Also, you can check how many pools were here. Here's like a 1 million plus. That means that this image is well trusted. You can trust it, and then you can download it and use it in your Docker setup. Then the next thing to try is the Docker linter. Docker linter, there is Hadolint. It's online version, this one, the one I'm showing, but also there is the version which you can run on the CI. So let's try to use this setup. If you take, for example, this one, and then you put it here, you click lint, no issues, fantastic. But if you change this to add, for example, you click lint, and then here you go. Use copy instead of add. So it will suggest you to do something about it. It will tell you that there is an issue, or if you do something like this, you see also the issue, because you need to pin the dependency and you need to put the version on it. There is also online version. You can see this Docker linter. I added a step, and then when I changed to exactly this code, we got this exception. So also the same, use copy instead of add, and also pin the dependencies. If you add this lint of Docker files into your checks, of course, that would be really nice to see if your images are secure enough. And you can see it here in the workflows, in the actions. I added it as a separate step, lint Docker file, and then this is from the creator of Hadolint, or maybe somebody integrated that, and we are checking the Docker file. So that's it, super simple, and also easy to check and improve on that. A bit more hints, just a few more hints about that. If you don't document your code until now, please do start documenting your code, because of course your code is a masterpiece, but if you leave the company, or maybe you onboard somebody else into your team, then that would be not so obvious what the code does to another person. So I highly recommend you to start with documentation, and you can also start now from this very second. There is a secret about documentation, and I want to share it with you. There are 4 types of documentation. I really like this documentation.devio.com, because it explains which kinds of documentations are there. There are tutorials, how-to guides, technical reference, and explanation. So choose the ones which you really need, the ones that would help you to onboard newcomers and also share the code. If it's open source or if it's a closed source, if it's just for you, still you need the documentation. How to start with Python documentation? Start as simple as possible, and then you can go to a version control documentation. I recommend you to start with Sphinx, and then you can also try read the docs. I also have a super tiny small demo, which would take a few seconds. If you want to check how to set up simple documentation with Sphinx and read the docs, you can go to this simple docs setup and then check, because there is a super standard read the docs file. You can take it also from read the docs themselves. Here is my setup for a read the docs open source edition. It's also free, and you can see all the builds 12 minutes ago. Every time when I push the new version, it runs automatically, and then it builds the version. And here how it looks. Of course, there is no documentation because I didn't quite write it, but you can also have the application reference, which would include the code. You can write everything in Markdown, and that would be a first nice start to your documentation. And a few books to read for you when you have time. Architecture Patterns with Python. I really like it. The Clean Architecture, Release It book. That's the book which I already mentioned. And of course, the Phoenix project. So how can everything be so broken that you will have to improve it and improve it fast? I would like to hear back from you about this talk. What can be improved for the next time? What did you like and what did you miss in this talk? You can also access all the code which I showed you today, all the examples under this GitHub repo, Can We Deploy Yet? And you can also see articles related to what I told you today on my personal blog. And of course, you're all invited for the PyBerlin meetup. So thank you. If you have any questions, feel free to ask if we have time.